Alright, so here I have my ever trusty unit circle. So the first thing you need to be able to do is just given the angle theta, and I'm going to focus on the radians case because degrees are usually easier for people. But given the angle theta, can you figure out the trigonometric values? In general, for an arbitrarily given angle, you can't do it by hand. You'd have to use a calculator. However, for certain special angles, like all the angles that I've listed here on the board, you can, and I'll show you how. So the first thing that we're asking for is, what is the cosine of negative theta? So how do we figure that out? Well, first, we rotate by negative pi degrees, right? Pi radians, excuse me. And so negative pi radians, remember, is the angle that corresponds to what you get when you move half of a revolution in the clockwise direction. If you do so, you end up on this side of the y-axis, and the point on the unit circle that you're at is right there. Now the coordinates of this point on the unit circle are -1 and 0. By definition, by our new definition of the cosine function as simply the x-coordinate of the point on the unit circle, the cosine of this point is equal to -1. Done deal, right? The sine of this same angle, negative pi, is equal to 0. Again, just because the y-coordinate there is equal to 0. Done deal. All right. The next angle we were asked to find is the tangent of pi over 2. Okay? So pi over 2 radians amounts to going 1/4 of the way. Because remember, a full revolution is 2 pi radians. And so we're only going 1/4 of the way around the circle here, and we stop here at the right angle. This corresponds to the point 0, 1 on the unit circle, a nice easy point to compute. And what do we see? Well, the tangent, remember, of any angle theta is equal to the ratio of sine of theta over cosine of theta. The extended definition of the sine and cosine functions that we just gave was that this should correspond to the y-coordinate of the corresponding point, and this should correspond to the x-coordinate. In this case, though, for this particular point, this turns into the point 1, 0, and so this is undefined. And so we write undefined. I will sort of point out that this does sort of jive with the definition of tangent that we gave that was more geometric. So remember, originally I said you can define the tangent as the length of the tangent line, how long the tangent line is, which touches the x-axis here, right, if you start the circle. And what you notice is as you get closer and closer to the top of the circle, the tangent lines get longer and longer until at some point right here, the tangent line here is perfectly parallel to the x-axis. It never touches it. It's approaching infinity. So that's the idea, is that we can see here visually that this does work. It should be undefined because the tangent line gets arbitrarily long. Okay, so those are the easy, straightforward types of computations that we can do. Now let's do a slightly harder one. We need to figure out the sine of 7 pi over 4. And the first thing we got to do is trace our finger around and go in radians. And so the way I like to do this is, I like to work in pies, right? So I know that, just to figure out where this angle lives in the unit circle, 7 pi over 4, what do I know? Well, I know that if I go in the counterclockwise direction this far, I've gone a full pi radians, right? So that's 4 pi over 4 radians, right? I need to go a further 3 pi over 4 radians, right? I need to go 3/4 of a little half twist here. So here we go. Add in. This brings me up to 4, 6, and then finally, boom, here I am. I'm at 7 pi over 4 radians. Just like this. And if I did this right, this should look like that. Okay. And if you ever want, I don't know if I recommend this. I think just following your finger and getting a feel for it is the best way to do it. But if you want a nice formula for where it goes in the circle, use that earlier formula I told you about conversions, right? In other words, 7 pi over 4, okay, radians, remember, is equal to 7 pi over 4 times 1 over 2 pi, which comes out to 7/8 of a revolution. So if you make the conversion from radians to revolutions by multiplying by 1 over 2 pi, that tells you how much of the circle you have to traverse. Here we see that we traverse the circle 7/8 of the time. So we go almost all the way to 7/8. That's another automatic way to do it. But like I said, you should try to develop a feel for these angles by just, doing it. But in any event, that's an automatic way to do it. And so now we just need to figure out what are the coordinates, the x and y coordinates of this point right here. And in order to figure these out, well, we know that these are just the ratio. The y is just this length, and the x is just this length. So let's go over here by ourselves. What we're looking at here, we can see, if we just focus on this triangle over here, we're looking at a 45-45 triangle. Now, in the 45-45 triangle I drew, okay, the side lengths here were 1, 1, and 2. I mean, 1, 1, and square root of 2, excuse me, right? However, in this triangle that we have right here, this radius is supposed to be equal to 1. And so what I do is I shrink every side length by a factor of square root of 2. In other words, I just divide every side length by square root of 2. So by dividing every side length by square root of 2, this hypotenuse just becomes equal to 1, and these two side lengths become 1 over the square root of 2. And for those of you who might not have seen this in a while, remember 1 divided by the square root of 2 is the same thing as the square root of 2 divided by 2, just by that algebra. And so what do I see? Well, I see that this x-coordinate, I know it's positive, so I know that is just square root of 2 over 2. However, the y-coordinate is negative, right? It's a negative 1 over square root of 2, or negative square root of 2 over 2, simply because of the quadrant it's in. So we use the 45-45 triangle to figure out the actual length of it, but we need to look at which quadrant the angle lies in to see whether the corresponding trig function is positive, negative, or neither. Okay. So let me do this again now with some new angles. I'm going to erase this. Of course, you can just fast forward through this quick erasure here. I need to start fresh with some new board. Okay, there we go. Next problem, we need to find the secant of negative 13 pi over 6. Again, the first thing I need to figure out is where does negative 13 pi over 6 sit on my unit circle? One quick trick to do, again, divide by 1 over 2 pi, like this, and I find out that this is negative 13 over 12 revolutions. So what does this mean? This means I go in the negative direction one entire revolution and then one more 12 right here. When I do that, I end up right here in almost the same location. The only difference now is that this angle right here is a pi over 6. This is a 30, 60, 90 triangle instead of a 45, 45 triangle right there. So that's the first step. I've located my triangle, and I know that this triangle inside the unit circle is a pi over 6, pi over 3 triangle like that. Okay. Again, another way to look at this, you don't need to use this conversion. I know that negative 2 pi brings me back to where I started. Negative 2 pi is negative 12. And so I add one more pi over 6 to get down there. Okay. So now I found the angle, and I know the kind of triangle that I'm dealing with, and I just need to find these two lengths to figure out what my x and y coordinates are. And again, the 30, 60, 90 triangle that I showed you has side lengths where this is 1, this is the square root of 3, and this is 2, right? But of course, my hypotenuse here is only equal to 1, so I shrink down the triangle by a factor of 2. So I divide the square root of 3 by 2, and I divide this side by 2, and I divide my hypotenuse by 2. I get a triangle which has the same shape, so it's the same sines and cosines come out of it, but whatever. Once I do that, I can see the coordinates of this actual point. The x-coordinate is positive square root of 3 over 2. The y-coordinate has a magnitude of 1/2, and since it's sitting down here, it's a negative 1/2. So this is my x, and this is my y. At this point, I've done most of the work. In fact, now I know these, I can compute any trig value at the angle negative 13 pi over 6. Okay? Going from here, I see that the secant of negative 13 pi over 6, well, what is that? Well, remember, the secant by definition is equal to 1 over the cosine of that same angle. And the cosine is just the x value, so this is 1 over the square root of the square root of 3 over 2, which is the same thing as 2 divided by the square root of 3 once the dust settles. And that is how you define the secant. The cotangent of the same angle, if I need the cotangent instead, I've already done all the hard work. I've located the angle on the unit circle, I've figured out the nice triangle that's associated with it, and I've used that triangle to figure out the actual coordinates of x and y here. Now I just need to plug in different things. The cotangent, by definition, is the cosine of that same angle divided by the sine of that same angle. And again, here the cosine is x and the sine is y. And so just plugging these in, then canceling the 2's, I get the negative square root of 3 at the end. And that is it. That is the general idea for computing angles. There are 2 big steps. First, locate your angle. Second, find the coordinates associated with that angle. And it's either going to be obvious because it's sitting at like a 1, 0 or a 0, 1, or it's going to come from one of the 2 triangles, 45, 45 or 30, 60, 90. Once you got that part done, the rest is just plugging and using the definition. Okay, so remember I already told you your first secret assignment that's in the middle of the video to make sure that you actually watch the video. And the first secret assignment was to, prove those ratios that, for example, the cosecant is equal to 1 over the sine of theta, etc., right? You remember because you watched it, if you're this far into it. Your second secret assignment is to, you guessed it, complete the unit circle, right? So here I've shown all the angles that we can easily compute, that can be computed exactly. All the angles that come from putting in either 30-60 triangles or 45-45 triangles. If you don't know what I mean by the unit circle, Google it. It's everywhere. It's the whole world. The point is that you should be able to construct the remaining angles down here. You can either make them negative angles, whatever angles they are, but more importantly, you should be able to compute the x and y coordinates of each of the points on the unit circle corresponding to that, and you should be able to compute the trig values, every single trig values, using those x and y coordinates. So the one thing that I want you to turn in to the substitute on Wednesday is your drawn out copy of the unit circle. I want the unit circle to be complete with all of the angles in radians as well as the x and y coordinates. And just for the heck of it, read off the cotangent at each point. And of course saying undefined if it's undefined. The real point of this is not for you to copy this off the internet. Try to build this thing from scratch using what I talked about in the lecture, using the same techniques. The techniques that I used to locate and all these angles and to compute their trig values can be used to build the unit circle from scratch. That's what you want to be able to do. If you prefer to just copy it off the internet, well, whatever floats your boat. Okay.